The objective today is to solve simple programming challenges when the set of allowed commands is constrained. So before we begin, a little extra credit opportunity here and a great moment to reflect on algorithms. I said that we will be creative in creating algorithms during the next lesson. So what I want you to do right now is write or draw an algorithm for Mr. H to use on his 5-year-old twins to get them to brush your teeth. Yeah, that's something I'm struggling with right now. One time I caught my son just standing there chewing on the bristles of the brush, like he thought chewing the toothbrush was the way that people brush their teeth. I have some things here for you to consider as you're creating this algorithm. Maybe consider motivation to begin. Consider the idea of flossing as a part of it as well. Consider the mouthwash use as a part, and maybe some rewards I can offer or incentives. One way to remember what the word algorithm means is just think like I'll go this way or I'll go that way. That's what an algorithm is. Some sort of branch that occurs depending on something. So if there's a yes, you go one way, and no, you go another way. If there is an on, you go one way, or an off, you go the other way. That's an algorithm. I'll go where, okay? So this lesson, though, is your first exposure to programming in the AppLab environment. AppLab is embedded in a Code Studio, and for this lesson, the student's view is limited to only a very few simple turtle commands to draw graphics on the screen. After a few warm-up exercises using only combinations of 4 drawing commands, you guys will figure out the most efficient way to draw an image on a 3x3 grid. The main purpose of this lesson is to start students on their programming journey in such a way that focuses more on problem solving than learning the syntax. Syntax is important, and it's a beast of a burden to bear, but to get through it, I think first you should learn the logic behind problem solving with programming languages. Then you'll be able to understand the syntax so much more quickly. So like the previous lessons about algorithms, stripping down the available commands to only a few, those constraints force students to think about the most efficient way to solve the problem and come up with creative ways of doing it. So a reason to learn this way is because at its core, a computer can only do a few things: load a number from memory, store a number in memory, and add 2 numbers together. Everything the computer can do is a result of combining these simple instructions to do more and more sophisticated things. Think, write, share. What 3 things can a computer do? So the big picture here, when programming at any level of expertise, you're always limited by the constraints of the programming language you choose. Whether the language gives you thousands of commands and libraries with which to control various things, or only a few, you always have to use those as building blocks to get the computer to do what you want. It usually involves being creative and making interesting choices about how to go about doing something. In this lesson, we simplify things dramatically by only providing 4 turtle drawing commands, namely move forward, turn left, pin up, and pin down, to produce simple drawings. In fact, the problems can be solved using only move forward and turn left. So, time to go play. There's 2 think, write, shares that come with these puzzles. Nothing on the first one, but the second puzzle I want you to answer, how did you turn right when there was no right command? And for the third puzzle, how many command instructions total did you use? And you'll go to the link right here in order to accomplish those puzzles. Efficiency definition: achieving some desired outcome while minimizing wasted effort or resources. If you've been in Mr. H's class this entire year, you know I love efficiency. I do not like wasting time, and I think that if we are all efficient, we will all have no problem learning the things that we need to learn in class. So, note that, depending on the context, the resources or effort may take many different forms. So other examples may include fuel efficiency in cars, energy efficiency in appliances or light bulbs, or even efficient use of space in apartments. For programmers, it is often a balance between the number of lines of code and the time it takes to create those lines. Heuristic versus algorithm is also a great idea or a great example of the idea of efficiency in computer science. So my think, write, share here, what does efficiency mean to you? And if we look at a chart like this, you can see that quality and efficiency may go up at the same time that cost is going down. So think, rate, share. What do you value most between these three? And this is obviously the ideal situation every company would want to find themselves: low cost and high quality and efficiency. So that was it for today's lesson. Pretty short because you're working on puzzles. Choose an IB question to answer here, anyone, to reflect on your thinking from today's lesson. And your DOL, please describe how you solved the 3 challenges in the App Lab. And you can explain each individually or one at a time, however you prefer. But I'm just looking for a description of how you approached those challenges.